In the second part of this video, we're going to touch on the time value concepts. So we're going to do some calculations, if you will. So if you have a spreadsheet available, the one that I've provided for this class, you'll be able to follow along. I suggest that you pause the video and make sure that you can get the answer that's shown on the page. So here we're going to talk about future value. And again, we're not going to mention this once, but there are a couple of ways you can do this. Sometimes there are tables that are provided where if you know N and R, the R here is the return. In this case, it does say K. You can just multiply the present value times that interest factor, or you take the present value times 1 plus the required return, and you take that to the nth power. So you can do it with a table, you can do it with a formula, you can do it with a financial calculator. I provide a worksheet, so the worksheet will solve all the answers. So the one thing we have to recognize, though, is that present values are always designated as negative numbers. It implies an investment today. So we're going to invest $1,000 at 10% for 4 years. So on that spreadsheet, negative 1,000 is the present value, interest rate's 10%, time in years is 4. We have, in this case, annual interest rates, what we're talking about, so that's 1. And the future value is $1,464.10. So if you invested $1,000 today and you actually earn 10% per year for 4 years, at the end of that time frame, you'd have $1,464.10. As a little bit of a curve to that concept, let's think about compounding frequency. How many times per year is interest calculated? So the compounding periods is the variable here, P divided by Y, periods per year. Now, I don't know where the M comes from, but in the finance literature, M represents the periods per year. So if you invested $1,000 for 6 years at 12%, and you compounded that semi-annually, and you plug in the data, $1,000, 12%, 6 years, but now you change the compounding frequency from a 1 to a 2. Now, there aren't too many choices here. 1 time is annually, 2 times is semi-annually, 4 times quarterly, and 12 times is monthly. I guess you could do daily, 365 days. So we end up with a value at the end of 6 years of $2,012.20. Looking at interest rates then, this obviously has to do with this compounding piece. Because if you compound more frequently, as we mentioned earlier, you earn a higher rate of return. So if M at 12%, if M equals 1, then the effective interest rate, the actual interest rate you earn, is that 12%. But what happens if we have monthly compounding? Right? So it means every month the interest rate, 12%, divide that by 12, you're going to get 1% every month. But remember, this is interest rate earning interest rate. It's compound returns. So it's going to grow faster. So at the end of the year, you would actually earn 12.68% instead of 12%. So moving on to present value then, what's the present value of $1,000 3 years from now if we can invest at 13%? So again, essentially the hardest part of this is, number one, is to know which worksheet to use. I'll help you with that as much as I possibly can. This is the time value of money worksheet. The hardest part then is just putting the variables, the numbers, where they belong. It's a future value, $1,000. You're going to earn 13% is what you can invest at. And you're going to do this for 3 years. So in today's money, this is worth $693.05. So what would you be willing to pay to get $1,000 in 3 years if you can earn 13%? And the answer is the most you'd be willing to pay, $693.05. Another type of a cash flow stream that's very prevalent in investing are annuities. Annuities is an equal cash flow stream for a certain period of time. Now there's 2 forms of this. An ordinary cash flow starts at the end of the period. The annuity due starts today. So we need to understand that there are differences in the phrasing of the questions, and that obviously will have a difference or make a difference in the value that's determined. So typically you're going to look for some words, some phrases. Here's the future value of an annuity. You're going to earn $5,000 per year, or you're going to invest $5,000 per year in an IRA until age 60. If you see nothing here about beginning of the year, then this is an ordinary annuity. Now, sometimes it might say $5,000 per year at the end of each year. Plugging into our formula now, into our spreadsheet, we're still on the time value of money spreadsheet. 12% is the interest, the time is in years, compounding frequency, 5,000 per year. And now we have a payment. This payment is negative $5,000. So you put that negative $5,000 under the payment, and down here we find that the future value of an annuity, what this investment will grow to, is $3.85 million. $3.835 million. If you change the frequency, instead of making $5,000 payment once a year, what if you divided that by 12 and you made $400 payments a month for the same time frame? So we need to change the compounding frequency to 12 and change the payment to negative 416. That gives us a value of $4.9 million. Now let me ask you a question. Do you think you would recognize the difference in your retirement account of roughly $1.1 million? I think probably you would. So here are some other types of problems we can solve for. You've determined that you need $1.25 million in 30 years to retire on, and you can earn 10%. The question is, how much do you have to invest on a monthly basis to get that future amount? Again, let's plug in the numbers. You need $1.25 million in the future. Annual interest rate, you can earn 10%. 30 years is when you want to retire, and the compound frequency is 12. To get this money, you're going to need to invest $552 a month. Let's assume that you've decided, that you've got that $1.25 million. You're ready to retire, and you want to withdraw an equal amount each year for 20 years. And you can still invest at 10%. How much money can you pull out per year? Well, if you type in here the compounding frequency once per year and go down and solve, we're solving for this payment, right? You're going to receive $146,824 a year in retirement for 20 years if you can earn 10%. Now, what if we change this to monthly? What would we need to do? All you need to do is change the frequency to 12. In this case, you would receive $12,062 a month for 20 years. And it sounds like a lot of money, but remember, this is 30 years from now. And that 20th payment at the end of your time frame, that's 50 years from now. These dollars are going to lose their purchasing power over time. One of the questions in investments has to do with changing values, right? You want to retire with $100,000 a year in income. You expect to live for 35 years and you can earn 8% on your money. How much do you need to acquire in your retirement accounts? So when we type this in, 8%, you're going to live for 35 years, you're going to get $100,000 is what you want to receive, right? You need to save $1.165 million. And that's fine, except you're going to live for 35 years. You're worried about inflation. So this table allows us to insert the growth of an annuity. We want this annuity, we want this $100,000 to grow by 4% per year. So how much will we need to invest if that's the cash flow we get? When you put in 4% here, down below, you'll see the present value of a growing annuity is $1.83 million. So give or take, about $700,000 more dollars need to be invested if you want to keep up with inflation. A special kind of annuity is something called a perpetuity. A perpetuity is just a cash flow. It's an equal cash flow that lasts forever. It has an infinite lifespan. So you want to start an endowment that's going to give your favorite professor, I'm assuming that's me, $20,000 a year, and I'm going to get that forever. The college can earn 10% per year. How much would you have to donate? Well, the formula is a simple formula. It's just the cash flow divided by the return. That's $200,000. But if you plug that into our spreadsheet, you can see $10,000 or 10%, $20,000 is what we're going to receive. The growth, if you wanted to grow by inflation, you can put 4% there. So what we find out is the present value of the perpetuity is $200,000. So if you invest $200,000 and you make 10%, then you're going to earn $20,000 per year, and that's exactly what you're going to pay me. What I would like you to do, though, is to calculate the 4% needs to go in this growth of a perpetuity box. If you type in 4% there, how much money will you earn or need to invest in order to achieve this cash flow stream? And I leave that up to you to work your way through that example. Next, this is a kind of complicated example, and I'm going to let you stop, pause this, and work through the spreadsheet to figure out these numbers. I've provided you with where the data goes, where the numbers go in the spreadsheet. But let's just work through the example. If you currently earn $50,000, you've already saved $15,000, you want to retire in 35 years at age 60, so obviously we're saying you're 25 years old, and inflation's 4%. What will your income need to be in year one of retirement to live exactly the way you are right now? We need to find the future value of $50,000. When you do that, you're going to find out that in retirement, you're going to need $197,000 to live like you're living with $50,000. Sounds a little scary, doesn't it? So if you expect to live to be 90 years old, how much do you need in your pension fund if you can earn 8% during retirement? Again, investing this $197, you're going to get that, receive that as a cash flow, as an annuity. You need $2.2 million to invest and get $197,000 a year for the 30 years in retirement. What if you wanted your retirement income to keep up with inflation? Let's say inflation's 4.5%. You then would need 3.5 million. So using that 3.5 million as the most we would need, how much do you need to invest on a monthly basis if you're going to save for retirement? Again, you're starting already with $15,000 and you can earn 12% on your money. If you plug the numbers into our spreadsheet, you'll find out that you need to save roughly $397 a month. So now let's think about this, $397 a month, but what if you work for a company that has a 401k that's going to match, let's assume they match dollar for dollar. Let's say that's $400. If you invest $200 and they invest $200, that's $400. You'd end up with $3.5 million in your retirement account. If you could invest the $400 a month and they match the $400, you'd actually end up with $7 million in your retirement account. So there's obviously some morals to this story of how you need to invest. Again, here's another example of how much what rate of return you need to earn. You currently have $20,000. You're 35 years old. You plan to retire at 25. You need $2 million in your account, and you're currently investing $250 a month, and your company matches that amount. So when you plug the numbers in, the payment that you're making is actually $500 a month. We leave interest rate blank here, and that then solves for this value down below. That in order to get this $2 million with only $500 a month investment, you have to earn 14.1%. Now that's a pretty high number to have to shoot for. So one of two things probably has to happen. Either you need to increase your investment, or you need to figure out maybe you won't be able to have $2 million. You might have to lower your expectations of the money you will need and the number you'll actually be able to spend when you get to retirement. So it's a good kind of a question to ask, is what I'm doing right now working as I'm planning? Another number to think about is something called internal return. This is the rate of return you earn if you purchase an asset today and you receive all the benefits that you expect to receive, right? So this is basically a question of return. So if you invested $1,000 and it turned out to be worth $1,400 in 5 years, what is the internal return? You're solving for the interest rate. That's the 6.96%. That's the return you would earn on this investment. Now, there are other questions we have for return, but that's the simplest example, if you will. The internal rate of return assumes interest on interest. This is a critical assumption. The downfall of this concept, though, is it assumes that all investment earned in the future is reinvested at the same rate of return as the original investment. And that might be difficult to do, especially if you find something that has a really good rate of return. So this reinvestment rate is the rate of return earned on interest on other income received over the future, right? So the fully compounded rate of return is the rate of return that includes interest earned on interest. We obviously want to incorporate the time value of money here. So the advantages of the internal rate of return over the holding period return is it uses time value of money. It allows investments for different time periods to be compared with each other. And if the yield is greater than what you expect, it tells you this is a good investment. The challenge is it is complex, especially for examples or investments that have more than one cash flow. So in this example, we're looking at a bond, and you're going to pay $1,025 for this bond, and you're going to receive $100 a year for 10 years, and the last year you're going to receive an additional $1,000. So what is the value of these cash flows? What's the value of the future cash flows? This bond is worth $1,064. The discount rate here is 9%. The present value is worth $1,064, and you're going to pay $1,025. So your net gain is what's referred to as net present value is $39. The internal rate of return on this investment is 9.6. So again, this is just it's a complicated formula, if you will, to figure out the values for returns, and it's especially difficult when we have more than one cash flow. So if you think about finding growth rates, right, there's lots of questions in investing about growth. The rate of growth is the compound annual rate of change in some financial quantity, such as the price of a stock or the size of its dividends. So we can calculate growth rates for many things, and it's a very common question in investing. So that's the end of the video on part 2 of return and risk. I'll see you in the next video.